Hey, welcome to my new devlog about Pixelblitz, our multiplayer 2D pixel game that we're developing, and I have some cool new features that I implemented. Last time we have talked about multi-directional animations that were not present. Now this time, if you walk up and down, we're looking respectively up or down, going left or right, depending on whether I'm in a positive or negative range for the y-axis. I'm going to use the up or down walking animation, and that should just work. So the second thing that's new, and that actually I can show you some code how that works. So if I go into game scene, we will have down here somewhere the D-pad notifying the game scene that the direction has changed, right? So hero node update is direction. So if we go into the hero node, which is basically an instance of character class, I'm gonna say, okay, derive the direction that I'm looking at from the vector. So I have a walking state enum that has a convenient function that takes in the vector, and all it really does is, if the vector is 0, which is basically standing right now, then return the walking state of stop, we're not walking. If the y value of the vector is above 0, return up, else down. That's it. Nothing fancy. And so based on the walking state, I'm saying, oh, up and down, whether up and down, I'm just going to say, okay, apply the new vector direction to the player so you can walk in that direction, right? That's going to walk. This is the walking direction times speed. I'm assigning the direction so I have it stored locally for the character. And then I'm saying, oh, and then now animate the character based on the walking state. So I assign the walking state to the character class, and here I'm using the assign walking state. And if you go into move animation, you will see that, based on if it's up, if we're walking up, right? And if I change a little bit, say I'm moving up and to the right, that's changing the direction, but I'm still walking up. So I don't want to run a new animation on top of the currently running animation. What I want to do is I'm saving the animation with a key. Or like I'm associating the animation with a key so that I can, when I change the direction but it's still up, I can look for the key, walk up key, and see, hey, is an animation present? Like it's not nil? Well, in that case, it's still walking. Early return. Like don't add new animations or, on top, or remove any animations. But if it's not present, that means remove all animations. Maybe before there was a walking down animation. The current animation is not walking up, but I've been told we're walking up right now. So remove all animations, basic actions, and then start the walking up action, which is the animation of walking up. Same applies for down, same thing. And then for stop, it just says remove all animation. And then depending on the vector, again, on the direction, if it's above 0, it's gonna use the initial up frame to like stop and just like look at you, which has like 2 legs. You see the 2 legs? If I'm walking, it doesn't have 2 legs. There's like 1 each. So at stop, if I stop after the direction was actually in the positive y-axis range, I'm going to use the initial up looking frame. And if it's down, I'm going to use the initial down looking frame. And so that's how I implemented multi-directional animation for walking, for the walking state. And this also allowed me with the walking state, it's string encodable. I can encode up, down, and stop to a string and then JSON, and then sync it across the network to the other device so that when I walk here down, when I walk down here, this guy is synced accordingly, the walking state. All right, the second thing is I re-implemented the fire button, and that was not that straightforward because when I tap here, I don't want the D-pad to move here, right? Because you can move the D-pad wherever you want, except when I tap the fire button, right? And so I had to identify, well, am I actually tapping the fire button right now? Don't move the D-pad here. Am I not tapping the fire button? Move the D-pad here. I can show you again how this works. It's basically when the game scene says, oh, touch began, I'm going through all the touches that are on the game scene, and I'm saying, hey, is the touch a touch on the fire button? Then give that touch to the fire button, right? Give that touch to the fire button, and the fire button is going to say, actually I'm gonna check it again. It's the same function, and it will just say did tap fire. So it's just gonna say, okay, I'm firing right now. If it's not the fire button, this very touch, then give it to the D-pad node and say, hey, the touch began here. So then I'm gonna say, I'm gonna store the current touch. That's very important. I'm gonna store the current touch. It's a class, so by reference. And then I'm gonna get the location, and then I'm gonna position the frame node and the joystick node, basically, where the touch is. Why am I storing the current touch reference? Because when I move a touch, when a touch has moved, I want to identify that what touch has moved, right? Was it a second touch on the right side of the screen? Was it the very touch I used to position the D-pad? Because that's what I care about. So when I say, oh, if a touch has moved and the touch is not on the fire button as well, right? Then I want to pass it to the D-pad touch moved. And here I'm making sure, okay, only continue this code if the moved touch is equal to current touch. Like the class, like the touch actually, because it's a reference, is the exact same. If it's the very touch, then we're calculating and you know, clipping to the moved location. And so that's how I implemented the D-pad in addition to the fire, and was able to differentiate between the both touches and handling some edge cases. That's working just like perfectly. And so finally, what you see on here is not running through a local host. The data that's being synced between the two devices is actually going through a server somewhere in the States. I deployed the backend to Heroku, and I'm connecting to that server right now. So this device is sending the data somewhere to the server somewhere in the States, and this device is receiving it from there and syncing up the enemy. And so this allowed me to deploy a build to test flight and start, and start testing it with 1 or 2 friends. I have 2 friends added to the test flight, so I was able to play test with one of my friends this morning to see if we can find any bugs. And sure enough, we found at least 2 bugs that I can show you too that are quite funny that I have to address. The first bug that we've identified is, you can see me here shooting and killing on my device. The enemy dies. On his device, he escaped the bullet just about an inch, right? Why is that? Because the bullets are not synced. The information that I just fired is synced, like sent along, and then by the time it arrives on the other device, he already like moved maybe an inch more. It arrived, says, okay, the enemy fires at the position, which is a little bit out of, you know, is not as accurate. Not the same very precision I actually fired off, but a little bit delayed. And so he escaped the bullet. So that's something I have to solve. And I'm going to solve it very, very easily. I'm going to solve it by simply just syncing the dev state. And I know it's not the best approach, but it's hopefully an approach that's good enough. And what I'm going to do is, of all players, whichever device identified a death first is going to be the dictator of the death for that character. So if I, for example, if I died, or if the enemy died on my device, I'm going to send this dev of this enemy to all players of the field, and this character is going to die for everybody. So that was one of the bugs that I'm going to address. Another bug that we found is actually when he fires so many bullets and I'm firing my bullets, the bullets are actually colliding. I'm just going to fix it by having the bullets not be able to collide. You can see already how the short delay of the data sync is introducing different outcomes of physics because the bullets are hitting themselves at a different point, right? You can see the bullets here are spreading differently than they do for him, because my bullets arrive at his point a little bit later and his bullets arrive at my point a little bit later, so a different angle. And so that also means that the bullets are, for me, not hitting him, but for him, he's running into a bullet because it's positioned somewhere else, which will be solved if I just not have the bullets collide. They'll just fly through, he escaped the bullet or not, and then we're good. That's the current state of Pixelblitz, where we are at right now. What I'm going to do next is I'm going to fix these 2 bugs, and I'm going to introduce a player name because I got already feedback. So when we open it up and see the feedback, there's going to be a few feedbacks already mentioned, and then player names is something I think is very, very cool, where before you start the game, you can enter your name and it will show up above the player, for example, or below the player maybe even, so we know who we're playing against. And once I have that, I will then probably move forward to lobby. Once I implemented a lobby where we can have 5 players at max, that would allow me to start sharing the test flight external link with you if you want to also start testing this game with me. So once I have lobby in place, I'll be start sharing the link, I think, so we can play test it together. And that's what that's the next step. All right, I think that's it. Basically fixing 2 bugs, introducing lobby. That's gonna be an interesting challenge. Maybe even an exit button or respawn button of some sort, so we can exit it and not having to restart the whole game. But that's it for now. Let me know in the comment section what you think, if you have any ideas, what I can add to the game, and I'll see you next time. Bye.